So we are going to focus on section 7.5, which is all about the vertex of a parabola. At the end, we're going to look at applications of the vertex, and let's go from there. So in the last section, we really introduced the vertex form of a quadratic. And that is right here. F of x is equal to a times x minus h squared plus k. So what if you are actually given a function, but the format in which you're given that function is standard form, and you want to change it to vertex form? The way that you do that is you apply completing the square. That's how you go from standard form to vertex form. The only difference is that instead of using the principle of equality, where you're going to figure out your n value and add it to both sides of the equation, we're actually going to do all of our work on one side of the equation. So we're going to add the opposites. It's the additive inverse property. We're going to add the opposites. So really what we're adding is 0. Okay? All right. Well, let's kind of see how this works. It's really not that bad. So let's take that highlighted quadratic function, x squared minus 6x minus 8. And the first thing we're going to do is we are going to separate the x values from that negative 8. Literally pull them apart. But we're going to keep it all on the same side of the equation or a function. So I'm just going to keep my variable terms, x squared minus 6x. Then I'm going to put a plus blank, okay, continue on with my minus 8, but I'm going to put plus blank again. So I want to reiterate, I'm on the same side of my function, same side of the equal sign. So whatever I put into these two blanks, I can't change the value of my function. So really what I need to do is add something that equals 0. That's what I'm doing. Okay, so let's go ahead and figure out what that n should be. I'm going to go ahead and, just like I did before, n is equal to 1/2 times that b value of negative 6, and then square it. So if I put that negative 6 over 1, that becomes negative 3 squared, which is 9. So that's what goes in that first blank. But I want everything in those two blanks, so the two highlighted numbers, to equal 0. So I'm going to take the opposite of 9, which is negative 9. Okay? So these two values are opposite. All right, so now I can take this first perfect square trinomial that I just formed, and I'm going to create a binomial squared. That's just going to be x minus 3 raised to the second power. Then I'm going to add negative 8 plus negative 9 to get a negative 17. So I've got f of x is equal to my function. That's done. Now this is in vertex form. And that's fabulous, because now I can do my next step, which is to identify the vertex, the axis of symmetry, and whether I've got a min or a max, which in this case it's going to be a min. All right, so let's go ahead and do that. So my vertex is going to be 3, negative 17. My axis of symmetry is going to be x is equal to 3. And then my minimum value is whatever my k is, which is a negative 17. Okay. All right. So now from here, I can move on and I can find my x and my y intercepts of this function. So I'm going to show you kind of a nifty way that you can find your x-intercept. If we go ahead and take our function in vertex form, change that function notation, that f of x, to a y, all right? And then you would let that equal 0. Or you could just kind of skip it. So for the x-intercept, my first step is I'm going to let that f of x equal 0. That's what I'm going to do first. Well, whatever, if you don't have to change it to a y, just because then you would just plug in a 0 anyways. So now I'm going to go ahead, plug that in. So that's going to be 0 equals x minus 3 squared minus 17. Okay? Now what I'm going to do, so that was my first step. My second step is to move my constant. So I'm going to leave my x minus 3 squared on one side, and my 17 is going to go to the other side of my equation. And now I'm going to apply my square root property. So I'm going to go ahead and take the square root of both sides, looking for both my positive and my negative roots. And so that is going to leave me with x minus 3 is equal to plus or minus the square root of 17. Well, the square root of 17, we all know, is not a perfect square. It cannot be simplified. It's just a prime number. So I'm going to leave that alone, that square root of 17. What I am going to do is solve for x by adding 3 to both sides. So that is going to leave me with, let's go ahead and put it up here. X is equal to 3 plus or minus the square root of 17. Beautiful. That's my exact answer. Well, that's not super helpful for graphing. That would be really hard to graph. I actually need something that's in a decimal format. So I'm going to have to put that into my calculator. So I get x is equal to, and my first number is going to be 3 plus the square root of 17. And that is going to give me 7.123. Then I do 3 minus the square root of 17, and that is going to give me a negative 1.123. Well, now I have numbers that I can actually graph. The only number that I kind of forgot is my y-intercept. So my y-intercept, recall, is going to be, I go back to where I had my standard form, and my y-intercept is just going to be that c value of negative 8. So these are my x-intercepts that I just did. My y-intercept is going to be 0 on negative 8. Okay? All right. So now let's go ahead and sketch this. So we have a vertex of 3, negative 17, which, of course, 1, 2, 3, 4, 5, 6, 7. There's negative 17. So 3, negative 17 is just roughly right there. All right. My x-intercepts, my first x-intercept is 7.123. So I don't know, that's right about here. And my second x-intercept is negative 1.123. I don't know, right there. And my y-intercept is 0, negative 8, right there. My axis of symmetry is right here at x equals 3. That's my axis of symmetry. And so because I know that a parabola is symmetrical, I can find one additional point super easy by going and looking at that y-intercept, seeing that it is 3 units from my axis of symmetry. And so I can go 3 units the other way. So now I can I've got a lot of points here. There we go. We can just sketch it that way. All right, let's go ahead and do this next problem. So this next one, I've got a negative in front of my x squared. So my leading coefficient is a negative. We never really like that. So the very first thing I'm going to do is I'm going to rewrite my function by taking out that negative. So when you have a leading coefficient that's anything other than a 1, watch what I do, okay? So I'm going to go ahead and take f of x equals, I'm going to separate my x terms or my variable terms from that constant term, just like I did before. So negative x squared plus 6x plus blank minus 5 plus blank. Okay, now here's what's a little kind of tricky, maybe, is I'm going to go ahead and I'm going to factor that leading coefficient of negative 1 out of the first and the second terms. So that's going to be my negative 1, and I'm left with a positive x squared minus 6x, and then I'm going to have that plus a blank. Okay, then I end my parentheses. And then I'm going to have my minus 5 doesn't change because that's outside of those parentheses or that perfect square trinomial. And this second sign is always a positive sign, so that's why that didn't flip. Okay, when you're doing that perfect square trinomial, you only apply that coefficient that you're dividing by or taking the greatest common factor out of those first 2 variable terms. All right, so now I'm going to go ahead and I've got negative 1. I'm going to go ahead and find that n value, which goes into that blank. So I'm going to take 1/2 of negative 6 squared, which is going to be negative 3 squared. All right, so that negative 3 is going to be 9. That goes right there. Well, you would think, based on what we did before, that because I'm putting a 9 here, I would put a negative 9 over in that second highlighted part. No, because it's not truly a 9. It's not a positive 9 that I just introduced into my equation. It's really a negative 1 times 9 or negative 9. So I took negative 1 times 9, which really I introduced a negative 9 into my equation. So my opposite is going to be a positive 9. So I put a positive 9 in that second blank. All right, so now I'm going to create my binomial squared, which is x minus 3 squared. And then I add negative 5 plus 9, which is a positive 4. Now I have this in vertex form. Okay? All right, so I want to find my vertex. My vertex is going to be 3, 4. Then my axis of symmetry is going to be x equals 3. And then, actually, I don't have a minimum value. I actually have a maximum value. My maximum is 4. And that's because of this negative 1, we have a parabola that's going to open down. So we are going to have a vertex which is at the maximum point of that parabola. All right, so now let's go ahead and find our x and our y intercepts. So our x-intercept, I'm just going to go ahead and take my vertex form, which is going to, and set that equals to 0. So that's going to be 0 equals -1 x minus 3 squared plus 4. Subtract 4 from both sides, so I get -4 equals -1 x minus 3 squared. Divide everything by that -1. And so I get 4 equals x minus 3 squared. Okay. So now I can take the square root, looking for both the positive and the negative roots of both sides. And so then I am left with x minus 3 equals plus or minus 2. Cool. So I'm going to add 3 to both sides. So I get x is equal to 3 plus 2, which is 5, and 3 minus 2, which is 1. So I have for my x-intercepts, I have 5, 0, 1, 0. Perfect. Now for my y-intercept, I just go back to where I started when I had standard form, which was my original, and I look at that c term, which is -5. All right, so then 0, -5 is my y-intercept. I've got all the information I need. Let's go ahead and graph this guy. So I'm going to graph it. First start with my vertex, 3, 4. Okay, I know this is going to open down. My intercepts are 1, 0, and 5, 0. And my y-intercept I just found to be 0, -5. I know because of my axis of symmetry that I've got 3 units from my y-intercept to my axis of symmetry. So that means I can go 3 units the other way and find another point. Super easy. So now I can sketch this, and my beautiful parabola is done. All right, you're doing great. Keep sticking with it. All right, let's look at the next one. Okay, so again, I see that I have a leading coefficient that is not a positive 1. It's actually a -2. So I'm going to go ahead, and first thing I'm going to do is separate that -2 from the 2 variable terms, or you can think of it as divide by that -2. So I'm going to pull out, I've got f of x equals, pull out a -2. Think of it as the greatest common factor between those 2 variable terms. So then I'm left with, so if I divided both of those by -2, I'm left with a positive x squared plus 2x plus blank. And then I'm not doing anything with that 11, but I'm going to do a plus blank. Okay. So I have to figure out what my n value is and put it into those 2 blanks in an appropriate way. So my n is going to be 1/2 times that b value of 2. I'm going to put 2 over 1 squared. Well, that's just 1 squared, which is 1. So I'm going to put a 1 right there. But it's not truly a 1 that I just introduced. It truly is a -2 times a 1. Okay, which is a -2. So the opposite of -2 is a positive 2. And that's what goes in that second blank. All right, let's move on. So now I've got f of x is equal to -2. I'm going to take this perfect square trinomial and put it down to a binomial squared. It's going to be x plus 1 squared. And then I'm going to add the 11 plus 2 to get a plus 13. There we go. Now I've taken my equation or my function from standard form to vertex form. Now I can continue on. So my vertex is going to be -1, 13. My axis of symmetry is x equals -1. And because I have a -2 as my a value, that means my parabola is going to open down. And so I'm going to have a maximum value. And my maximum in this case is 13. It's going to be the k value of that vertex. Okay. All right. So now let's find our x and our y intercepts. So our x-intercept, I'm going to do it the same way I've been doing it. I'm going to take my function that I've got here in vertex form, set it equal to 0. Okay, so to find my x-intercepts, it's going to be 0. Actually, I'm going to put the 0 on the other side. It doesn't really matter, but so I'm going to go -2 x plus 1 squared plus 13 equals 0. All right, I'm going to subtract 13 from both sides. So I have -2 x plus 1 squared equals -13. Divide by -2, I get x plus 1 squared equals 13 over 2. It's a positive fraction because a negative divided by a negative is positive. Now, I want to go ahead and take the square root of both sides, looking for both the positive and the negative roots. So that's going to leave me with x plus 1 equals plus or minus the square root of 13 halves. Subtract 1 from both sides. And so that's going to give me x equals, I'm going to have two x-intercepts. My first one is going to be -1 plus the square root of 13 halves. I'm going to tell you that is approximately equal to 1.55. Then I'm going to take -1 minus the square root of 13 halves, and that is approximately equal to -3.55. All right. My next piece of information that I want is my y-intercept. That is just my c value, and that is 11. Okay? And so 0, 11 is my y-intercept. So I can quickly graph these. So I always like to start with my vertex, -1, 13, right about there. My two x-intercepts, I've got 1.55, so that's about 1.5. And then negative, about 3.5. And then 0, 11 is my y-intercept. Because of my principle of symmetry, I know that my other point opposite of that y-intercept is going to be right there at -2, 11. Okay, so now I can go ahead and sketch. All done. Beautiful. All right. All right, here we go. I'm going to actually, for time purposes, just move on to the next thing, which is the vertex formula. So, yes, one great way of finding the vertex is what is the strategy we just used, to go from a quadratic function, which is in standard form, and put it into vertex form. Super easy to pick the vertex off. All right. Another way or another method of finding the vertex is to use what's called the vertex formula. Okay, so here you are. You've got your quadratic function that's in standard form, and you can take and to find the h value of your vertex, or some people like to think of it as the x part of your ordered pair. Okay, all you do is you use that formula, negative b over 2a. That's it. Then what the second part is to find the y part. So that gives you your x. This y, all you do is plug the x value into your original function. That's all. Okay. You could get fancy and use this to find the y. Use that formula right there. You could. Okay. Most people make mistakes when they try and use it, so I would recommend it's kind of easier just to plug and jog. All right, so let's give this a whirl. Let's start with this example here. Here we've got a function. It's a quadratic. It's in standard form. So the first thing that we want to do is we want to go ahead and identify our a, our b, and our c. So our a is 3. Our b value is -4. Our c value is 1. So to find our x, part of our vertex, that's going to be -b over 2a, or negative of -4 over 2 times 3. So that's going to be 4/6 reduced gives you 2/3. Okay, so now to find the y part of our vertex, I just plug it into that quadratic function. So that'll be 3 times 2/3 squared minus 4 times 2/3 plus 1. Okay, you can either put that all into your calculator or you can do it manually. I've already done it, and I'm just for time, I'm going to tell you that you get a -1/3. So our vertex is 2/3 -1/3. That's our vertex. Okay. Now let's find our x and our y intercepts. So our x-intercept, well, we didn't put this into vertex form. So we can't use that nifty, bring our constant over, apply the square root property. That wouldn't make sense. Instead, what we're going to do is we're going to factor. So we're going to factor that original function. So it's going to be 0 is equal to 3x squared minus 4x plus 1. So I'm looking for what can I multiply that gives me a +3 that adds to a -4. Okay, -1, -3. So I'm going to use that to split my middle term. So I've got 3x squared minus 1x minus 3x plus 1. Use grouping. And I can take out an x out of that first group. And so I'm left with 3x minus 1. I can take out a -1 out of the second group, and I get 3x minus 1. So our two factors are going to be 3x minus 1 and x minus 1. All right. Set both of those equal to 0. And x minus 1 equals 0. So then with the first one, I get x is equal to 1/3. And the second one, x is equal to 1. Those are your two x-intercepts. Our y-intercept is just like we did before. Same as our c value, 1. So it'll be 0, 1. Let's sketch it. All right, so we've got our vertex at 2/3 So we just approximate our x value is 2/3, go down 1/3. So there's 2/3, negative 1/3. Okay? And I know this is going to open up because my a value of 3 is positive. My my x-intercepts are 1/3, right here, and a 1. There we go. And my y-intercept is 0, 1. All right. So I can go ahead and sketch this. Because I'm dealing with fractions, it's not super easy to find the exact value that is symmetrical with that y-intercept. That's why I just kind of eyeballed it instead of finding the exact value. All right, let's do another one where we're using the vertex formula. So here's the given quadratic function. We're going to use the vertex formula in order to solve or find the vertex. So our x is going to be negative b over 2a. Well, our a is 1, our b is 4, our c is 3. So that's going to be negative 4 over 2 times 1, or negative 4 over 2, which is negative 2. To find our y, we just plug it in. So that's going to be negative 2 squared plus 4 times negative 2 plus 3. Okay, and so that is all going to add up to negative 1. So my vertex is negative 2, negative 1. All right, let's find our x-intercept. So our x-intercept, if I set my original function equal to 0, I just factor. And because there's a 1 as my leading coefficient, super easy to factor. I'm looking for what can I multiply to get 3? Well, that's just 1 and 3. So it's going to be x plus 1, x plus 3. Okay? Set both of those factors equal to 0. This is applying the zero product rule. And then solve. So x equals negative 1, x equals negative 3. Those are my x-intercepts. Right there. My y-intercept is simply going to be that c value of 3. There we go. Let's go ahead and sketch this. So our vertex of negative 2, negative 1, there we go. Then we've got our x-intercepts, negative 1, 0, negative 3, 0, and our y-intercept of 0, 3. We've got our, right there, our axis of symmetry. So because our axis of symmetry is 2 units, we can go then 2 units the other direction and get an additional point, and then we can sketch. There you go. That worked out beautiful. All right. So let's do this one where we've got a leading coefficient that is not a positive number. It's negative. So that means we're going to have a parabola that opens down. Okay. So first thing I'm going to do is use my vertex formula. So my A is negative 1, my B is negative 4, my C is 5. So I'm going to go ahead and find the X part of my vertex. So that is going to be a negative of negative 4 over 2 times negative 1. So that's going to be 4 over negative 2, which is negative 2. Now I'm going to go ahead, plug that right back in. So I've got the negative of negative 2 squared minus 4 times negative 2 plus 5. All right, that all together gives me 9. So my vertex is going to be negative 2, 9. My x-intercept, okay, I'm going to set my original quadratic equal to 0. So that's going to be 0, 0 equals negative x squared minus 4x plus 5. All right, I'm going to go ahead and pull out a greatest common factor of negative 1. So I've got, when I do that, basically all I'm doing is dividing every term by that negative 1. And so that's going to give me 0 equals x squared plus 4x minus 5. Okay, so then when I factor that, I end up with 0 is equal to x plus 5, x minus 1. Solve, and I get x is equal to negative 5, x equals 1. Those are my two x-intercepts, negative 5, 0, 1, 0. All right, then my y-intercept is again just that c value. So it'd be 0, 5. Let's go ahead and graph it very quickly. So our vertex is negative 2, 9. There we go. I know this is going to open down. So it makes sense to me that I've got x-intercepts of negative 5 and 1 and a y-intercept of 0, 5. Okay, there's my other point that's symmetrical. Go ahead and sketch. There we go. Beautiful. Okay, let's look at 2 applications. So here we have a projectile that is thrown upward so that the distance above the ground after t seconds is defined by that quadratic. After how many seconds does it reach its maximum height? Okay, let's kind of understand this a little bit. What in the heck are they asking for? So if I was to put this all on a coordinate plane, okay, and so my height is kind of like my y's, and time is along my x-axis. And so right here, that maximum is my vertex, which is going to have, the coordinates are going to be t, h, okay? T is like my x, h is like my y. So if it's asking for, the question is saying, find time. That's what it's saying. What is t? When you're at your maximum height, okay? So I'm going to go ahead and take my quadratic and just go ahead and solve this. So I'm first going to look for my vertex. That's the x value or the t value, and that's going to be a negative b over 2a. And so that's going to be the negative of 462 over 2 times negative 11. And so that's negative 462 over negative 22, which gives me an even positive 21. So what does that mean? It takes 21 seconds to reach the maximum height. And then gravity will pull it down. All right, let's look at a business application. So the manufacturer of a flat screen TV has found that revenue in terms of dollars can be modeled with this quadratic. Okay, So when the unit price is P, we want to find out if the manufacturer sets the price to maximize revenue, what is the maximum revenue going to be? Okay. All right. So our vertex is going to be our price, and then our revenue is going to be like your Y. And so the first thing we want to do is find that price that we need in order to maximize revenue. And so I'm going to use the vertex formula. So that's going to be a negative, my B is this 1200. So negative 1200 over 2 times negative 4. Negative 4 is my A. And so that is going to give me 150. So that means that $150 is the price needed to maximize revenue. All right. So now what do I do? Well, now I just plug that p-value into my function. So that's going to be R of 150. And it's equal to negative 4 times 150 squared plus 1200 times 150. So I just plug that into my calculator. So that's going to be negative 4 times 22,500 plus 180,000. Well, that negative 4 times 2250 is a negative 90,000 plus 180,000. So this all becomes 90,000. So that means that my maximum revenue is 90,000. That's the maximum revenue I would get, and that happens when my price is $150. All right. So now you shouldn't hang on. You should know what you need in order to finish this homework that goes with this section.